Okay, solving an equation involving logarithms on both sides. And Alex, it's problem type 1. So our first example, log base 2 of x minus 5 equals negative log base 2 of x minus 8 plus 2. So first we're going to move the log to one side. So it's easier, we don't want to move this over here, let's move this away so the logs are on this side and we have a number on that side. That's the setup we want. So to move this over to this side, we're going to do the opposite of subtract, or negative, which is plus. We're going to add it to both sides. So we get log base 2 of x minus 5 plus, add it to both sides, log base 2 of x minus 8 equals 2. And now, just like in the last lesson, these will always have the same bases for all these problems. We want to write with a single log. Alright, so we're going to get log base 2. And we did this with ln the other day. We started off this unit with doing this with log. Okay, because we have a plus here, what do we do with these two pieces? Okay, because we have a plus here, we're going to multiply those two pieces. And now we have to write as an exponential equation. So remember, it's the base, and you just switch these two. So 2 to the 2 squared equals x minus 5, x minus 8. Okay, now you have to simplify. You're going to have to FOIL this side. X times x, x squared. X times negative 8, negative 8x. Negative 5 times x, negative 5x. Negative 5 times negative 8 is plus 40. So 4 equals x squared minus 13x plus 40. Now our x squared is positive. I'm going to move the 4 to this side, because whenever we're trying to solve and factor, we want this equal to 0. So subtract 4 from both sides, we get 36. Okay. So what multiplies out to 36 that adds up to negative 13? We get, you can think about that for a second, x and x in the lead, and the two numbers that work here, you can pause it if you want to, I'm going to move on, is a minus 9 and a minus 4. Negative 9 times negative 4 is 36. Negative 9 plus negative 4 is negative 13. So if you solve this, you set each piece equal to 0 in solve, our zero products property. Add 9 to both sides, add 4 to both sides. If you can jump right to the answer, I'm okay with that. So now we have to, in this problem, check your answer. And the key is, if we have the log of x, okay, x has to be greater than 0, no matter what the base is. So I'm going to put base a because it doesn't matter. So log base a of x is greater than 0. So the way I check it, which is quicker, go back to the original. If you plug in 9, okay, so if you plug in 9 here, I get 4. If you plug in 9 here, I get 1. Okay, taking log of positive numbers, that works. If you put it in your calculator, it will work. It's just easier just to know the rule. Now, if I take 4, if I plug 4 into either of these, I get a -1 and a -4. That's no good because the value here has to be greater than 0. So x equals 4 is what we call that an extraneous solution, so that one does not work. So the only answer that works here is 9. Okay. So for these problems, you have to go back and check. You could use your calculator, but I think it's just easier by making sure that you can even have looked here, original or here. Plug in 9, positive, positive, good. Plug in 4, negative, negative. As long as one of them is negative, you can stop. So I can say 4, this is negative, no good, doesn't work. As long as it doesn't work in one piece, it doesn't work. Okay, so that's called an extraneous solution. They don't ask, I don't think they use that terminology, but that's what it's called, just in case you see it somewhere. Okay, so 4 is an extraneous solution. It's an answer that does not work. You do get a correct answer of 4 from this, but it does not work in the original. And that will conclude part 1 of this lesson. I'm going to do a part 2 where I just work out examples with you.